In previous chapter, we discussed different kinds of motion. We discussed linear motion. There is two kinds of linear motion. One is one-dimensional, and another one is two-dimensional. In two-dimensional linear motion, we discussed projectile motion. Then we discussed circular motion. There is one common and important type of non-uniformly accelerated motion, which is called periodic or harmonic motion. So there is another kind of motion which is known as periodic or harmonic motion. This important type of motion is the to and fro or vibrating motion. So this important type of motion is to and fro, or we can say that vibrating motion. To and fro means it oscillated in that manner, or vibrating means is oscillated in that manner. Okay. So it says that this important type of motion is the to and fro or vibrating motion of objects stretched or bent from their normal position and then released. Okay, suppose there is a spring. If we stretch this spring and release that, then it will vibrate in this position, and this is its mean position. Okay, this is its mean position. So this spring will move back and forth in this manner or vibrating in this manner. Such an object moves back and forth along a fixed path. This is its fixed path. Okay, this type of motion is produced by varying forces, and hence the body experiences varying acceleration. So if I vary force, then our acceleration will be vary acceleration. There is some example of this kind of motion, which is motion of spring. Okay, then vibration of a tuning fork. Vibration of a tuning fork. Motion of planets around the sun. Are some example of periodic motion. Okay, so I hope you understand these three kind of motion. Now let us talk about what is the definition of periodic motion. So first of all, we have to know the definition of periodic motion. So periodic motion says that a motion that repeats along the same path after a definite interval of time is called periodic motion. Suppose we can take an example of Earth's motion around the sun. So suppose this is a sun and the Earth is moving at that manner around this sun. So it says that a motion that repeats along the same path. The Earth is moving in that manner again and again and again every day. So it says that repeats along the same path after a definite interval of time. The time period of our Earth is 365 days a year. 365 days a year. So every 365 days, it actually complete a round around the sun. So definite interval of time. So this is our definite interval of time, and this kind of motion is known as periodic motion. So you can say that the Earth's motion around the sun is known as periodic motion. There is another kind, the motion of hands of a clock. Hands of a clock means the hands of hour and minute and second is also this kind of motion is also known as periodic motion, etc. Okay, so I hope you understand the definition of periodic motion. Now we will see what is vibration or oscillation. So what is vibration or oscillation? So it says that when a body moves back and forth repeatedly about a mean position. So when, suppose, let us take an example of pendulum. This is our pendulum, and this is its mean position, and this is the maximum displacement of of this pendulum oscillating in that AOB path. Okay, so when a body moves back and forth, so when we take this pendulum at that B point and release it, it again comes to the O point and again go to the A point, then again come to the O point and again go to the B point. So it says that when a body moves this kind of back and forth about a mean position, this is our mean position, its motion is called oscillation or vibration. So I hope you understand the basic concept of oscillation and vibration. So alternately, if the periodic motion of an object is such that during half of its time of period it stays in one direction and during rest of half in the opposite direction, then the type of motion is called oscillation or vibration. So if suppose if this pendulum is a periodic motion, the pendulum motion is a periodic motion, and if the time in the time of OB, this O to B, and the time of OA is actually equal, and this is the whole, and this is the half of its time period, then this kind of motion is known as oscillation or vibration motion. Okay, here some example of oscillation or vibration is simple pendulum. I just draw this thing, simple pendulum. Okay, then vibration of a tuning fork, then motion of a spring, These are some examples of oscillation or vibration. Okay, now as our chapter mentioned, this is simple harmonic motion. Now we will see the definition of simple harmonic motion. In our whole video, we will represent this simple harmonic motion or simple harmonic oscillation as SHM or SHO. Okay, so what is the definition of simple harmonic motion? It says this: the type of vibratory motion of a body such that the restoring force or the acceleration acting on the body is directly proportional to the displacement from the mean position and always directed towards the mean position is called simple harmonic motion. So it says that the acceleration acting on the body or the restoring force, suppose we represent this restoring force F of S, or our acceleration is A. It says that this restoring force or the acceleration acting on the body is directly proportional. So it is proportional to the displacement from the mean position. So suppose we represent this displacement as X, then it will be equals to X. So A is also proportional to X. A displacement from the mean position and always directed towards its mean position, That's why we will add a minus sign towards our displacement. Now let us take an example of a spring. Okay, then you will understand the why we use this minus sign. So suppose this is our X and we attach an object of M, mass of M, in that spring. So this is our mean position, or we can say that this is unstretched position. It is unstretched position. Then we stretch this spring from this mean position to some position of X. Then this X will always directed towards the mean position. So it this x is always try to be go to the mean position. So when we applied some force, or when we accelerated this uh, body in the downwards manner, the displacement always act in the towards the mean position or in the opposite direction. So these directions are opposite. That's why, as this is a vector, this is a vector and this is also a vector, force and displacement is vector and acceleration displacement is vector. That's why we use a minus sign in front of this uh, in front of the displacement. Okay, so this is the known case of our simple harmonic motion. So when we find out if a periodic motion, so if the a periodic motion has this kind of property, so this kind of property where its acceleration is actually proportional to the uh, displacement, and here the displacement is always actually directed towards the mean position, or the restoring force is proportional to the displacement, and the displacement is always directed towards the mean position, then this kind of motion is known as simple harmonic motion. Okay, now if I discuss some characteristic of simple harmonic motion, then it will be clear. So it says that its motion is periodic. So our simple harmonic motion will be always be a periodic motion. At a particular time interval, the motion becomes opposite. Why the motion becomes opposite? Suppose this is our pendulum. So this whole time interval is t. Then the half time of interval it moves in this direction, and other half of time interval it moves in this direction. So these two time intervals are actually opposite. Its motion is along a straight line. We'll discuss this thing later of this chapter. Then the fourth one is its acceleration is proportional to the displacement. Its acceleration is proportional to the displacement. Then it says that acceleration is opposite to the displacement. Our acceleration is always opposite to the displacement, we discussed in our earlier slide. And the last one is acceleration points towards the mean position of the object, and our acceleration points towards the mean position of the object. So it always try to come to the mean position of our object. Okay, so I hope you understand these concepts of simple harmonic motion in this video. In our later videos, we will see some definition, some formula, some equation of simple harmonic motion. This is one of the easiest to understand about this motion theory. So I hope you understand this video. Please like this video and do subscribe to our channel. Thank you.